Chapter 6, number 5 says, a coin placed 30 centimeters from the center of a rotating horizontal turntable slips when its speed is 50 centimeters per second. A. What force causes the centripetal acceleration when the coin is stationary relative to the turntable? Alright, so for chapter 6, number 5, we're first given that the radius, or how far it is from the center of the turntable, is 30 centimeters. And we know that the velocity of the turntable is going to be 50 centimeters per second. And then in part A, it wants us to find the centripetal force, or the acceleration that makes it so it's going to stay on the turntable. And then for part B, it wants us to find the coefficient of static friction. So for part A, the force that's going to be the thing that keeps it on the table is going to be the static friction. And this is because before the object even moves, static friction is what's keeping it in place. So if I have something and then I'm trying to push it, static friction is what keeps it from moving. So therefore that's what's going to be keeping it on the turntable as it's spinning around. Part B asks, what is the coefficient of static friction between coin and turntable? Alright, so for part B, the first thing we need to do is we need to get sort of a net force equation, sort of. So it's going to be MA, which is just the normal force equation, and then it's going to be I, and I'll explain these in a second, equals the force, which is kind of like the static force, I, plus N, the normal force, J, plus mg, and then negative j. So these j's and i's, they're pretty much just trying to tell us that they're vector quantities, meaning they both have a magnitude and direction, since they're going to be a force. And then this is negative j because it's going to be in the downwards direction. Like I have the coin, okay, and then there's going to be the normal force, and then there's the force of gravity, mg. So first what we're going to do now is find the total, or like the sum of forces in the y direction. And this is going to be equal to 0 since it's not moving. And then it's going to be n minus mg. And that's just from right here. So you could also write this as n equals mg. And then the next thing we're going to do is find just the total forces in the x direction, you could say, or r, I guess, if you want to use r, equals m v squared over r. And then this is just the centripetal force equation. It's m times a, and then centripetal acceleration equals v squared over r. And this is equal to the frictional force F, which equals mu sub n, and then, or not sub n, just times n. And then n equals mg as we found above, so it's going to be equal to mu times m times g. And then from here, we rearrange for the coefficient, which is mu, equals v squared over r times g. And then when we plug in all the values we have, so we have 50 centimeters per second, which is one of our givens, and you square that since it's squared, and it's over the radius, which is 30 centimeters, and that's times gravity, which is 980 centimeters per second squared, and that comes from dimensional analysis. And then the total answer is going to be 0.0850. This has been Chapter 6, Number 5. Thanks for watching.